We are going to talk today about going reactive with Spring Data. My name is Mark Paluch. I'm working with Pivotal on the Spring Data team, and that's probably the reason I'm here today. And let's talk a little bit about the problem space we are today. Well, when you are accessing data today in today's programming models, these programming models tend to make certain assumptions on resource usage. And in particular, it starts all with threads. Imagine you have a web application like that. You have a request facade, you have data access layer, and a remote data service. Then the request is coming in through the application. It hits at some point the remote data service. The remote data service takes a little bit of time until it responds to your application. And that's a thing called I/O wait. And if you take a very detailed look on what your application is supposed to do, you will find out that in most cases, you are waiting a pretty long time for your data to come back to your application. And that's time where the thread on which this thing is executed is blocked. So this thread is exclusive to this request and cannot be used by anybody else. After some time, perhaps, the remote data service starts answering, maybe fast, maybe slow, and you start processing the data and return the data from a request. But the request, or better said, the one who initiates the request is still waiting. So this isn't cool. Additionally, you create a lot of lag in there, so this isn't something which is great, actually. So what can you do to eliminate lag? Well, you can do things like bulk fetching, so fetching more than one record in a server round trip. This minimizes the lag per record you receive, so which is cool. You perform multiple calls, and you get a lot of more data with less lag per data item. So all that happens, but still, this one in the front is still waiting. You could say, okay, well, I attended Dimitri's session today. I've learned a lot of stuff about asynchronous data access, and let's take the future route. So you imagine you have two data services. One is a little bit bulky and not so fast. The other is maybe a little bit faster. And what you can do is you can fork off the request as it comes into the application. So both data services get a request. You pay the latency fee only once because asynchronous processing spins off something which runs in a background, and you do not pay that penalty on your request thread. This is cool, but what about the data which is coming back? Well, one service is maybe faster, the other takes a little bit longer, and you still come to the conclusion, okay, well, I have to wait at least as long as the slowest component in my data access chain. Additionally, you are required to do synchronization. And concurrency is hard, doing synchronization is hard. That's nothing you want to do within your business logic. But you can, if you like to. But the end is, well, the request is still waiting. So you can get some benefit out of that, but that's nothing which is entirely cool to your application. So I think we need to change a little bit what we are doing. Conditional data access, oh, crap. In the end, asynchronous data access, it's a technique to keep more threads busy than just the one you are doing. And another issue which is true about asynchronous programming is, well, before Java 5, we hadn't really something like the future. That arrived with Java 5, And everybody who programmed with Java 5 futures, well, who used futures in the past? Is it fun? Okay, I don't really hear a common yes. Well, if you deal with Java 5 futures, you deal with callbacks, you get into a callback hell. This improves a little bit with Java 8 because you get then completion stage and completable future. But still, you have the characteristics of an asynchronous data access. So you trigger something within your request thread. You have to synchronize it. And the true response processing effectively starts at the time all data is available to your application. So what else are the characteristics of today's data access? Well, you keep connections busy because we tend to assume we are the one in charge of using a connection. So we issue commands on that connection. We keep that connection within our data access request. And nobody else is able to use that connection, even though the connection might be usable for somebody else. This causes connection contention, which means that if you have something which pools on connections, like JDBC, you have to have an appropriate size of the connection pool. This may be 10, 50, 100, 200 connections. And if you put multiple boxes to each other, because every box runs your application instance, you have 400, 600, 800 connections on your database server. And that's not cool for the database server either, because every connection has management overhead. It allocates memory, at least the part which comes from a Linux kernel. And having an excessive number of connections just is a waste of resources. So asynchronous isn't a good answer. Synchronous isn't a good answer either, because, well, what happens if I run out of resources? Well, I have to scale. And data access and the way how we access, perform our remote service access is tightly related to scalability. Because, well, when you run out of threads, what do? Well, you extend the thread pool until you reach the max. What happens if you reach the max number of connections? Well, you either put another set of boxes, which is the microservice idea, or you scale vertically by buying bigger boxes. In any case, you have to have additional hardware, and if you're switching from a monolithic application to a microservice application, well, you might switch perhaps the application, but you won't necessarily buy new hardware for that. And every application instance you spin up eats up resources, eats up threads. So that's one of the reasons you have to care about scalability. Well, to do so, well, we have to change something. And we have to change the way our assumptions are working. We, at a Spring team, have a definition of what reactive means to us. When you ask a lot of people, what does reactive mean to you, you get at least 10 different answers. And reactive is a very overloaded term right now. In our understanding, reactive means changing the programming model to achieve maximum efficiency on resource management. And to do so, we have to change the level of our abstraction. We will use data as a stream, and we will take a look on the reactive execution model. But first, what does this really mean in the context of data access? Well, when we work with data for retrieving data, saving data, we usually use things like a single object, which is T in that case, or when we preload a list, then that's a list of T, or an iterator of T in a synchronous world. In an asynchronous world, it's a little bit different. We have a future of T that gives us the one element, or we have a future of list of T. In any case, we can iterate over the data. And while iterator is a thing which is less opinionated about the backing data structure, a list is very opinionated on the backing data structure because it gives you the promise, okay, you can access data by index, you know the size up front, and yeah, you can iterate on that. If we reduce that to something like an iterator, we can still iterate over the data which is available. We can ask the iterator whether there is more data. And a similar thing is true for a future, because at some point you have to synchronize the future unless you are writing a web server, and then basically you do not care what happens on that. But in most cases you are executing business logic, data access on the future, so you have to retrieve the result which is coming back, or you work with callbacks. So this way of data access is pull-based access. So the requesting thread pulls on the data structure. And that's tightly coupled to the way how we do assumptions on our resource usage, because we know we own the thread, so we can pull on the data structure. With reactive, this changes a bit, and depending on which reactive library you use, there are different data types. So quick question around, who of you has heard of RxJava? Quite a few. Reactive Streams? Okay. Akka Streams? Cool. So we in Spring use Reactive Streams as our base specification. And for all of you who know RxJava, there is also RxJava in version 2, which also is based on the Reactive Streams specification. And Reactive Streams is going to happen in Java 9 with the Flow API. So that's a common standard across all these reactive frameworks. And what Reactive Streams basically specify is, it specifies a set of interfaces, and the most significant interface is a publisher. It's a publisher of T, and what the publisher basically does is it abstracts the opinion of the underlying execution model for you, and it abstracts to some extent the multiplicity of the emitted data. In a reactive execution model, you get data emitted by subscribing to the publisher, and while you subscribe it, then somebody else is going to fetch the data for you without being opinionated whether that's happening synchronous in a blocking way or asynchronous, or even synchronous in a non-blocking fashion. So that's everything hidden by the publisher. The other aspect of the publisher is it's no longer a pull-based strategy, but it's a push-based strategy. So as soon as data comes in from your HTTP request, from your database, from whatever system you have, the I/O thread at the very end pushes the data through the stream up to the receiver. And this looks like the following in a picture. You have a subscriber, which is the piece which is interested in receiving the data. You have a stream, you can apply modifications to the stream, and on the very end you have a publisher that requests the data for you. What happens is, in your application, you set up the stream, you notify the publisher that you are interested in receiving data, and as soon data is available on the publisher publishes the data. And because this animation is so cool, I have to replay it once again. So you see, the upper part is very, very small, very, very slick. It does not block the thread until the data is received, but it notifies the publisher, hey, I'm interested in receiving data, please submit me data. And once data is available, the publisher will publish the data. Nice thing about this is we no longer block the main thread of the application. So something like a web request simply goes back to the data source, performs a signal, okay, I'm interested in data, comes immediately back, and then the reactive execution happens, which is the publisher is starting to emit data. a nice thing about the Reactive Streams specification is, well, it's immutable. So once you have set up one stream, you can't change the stream afterwards, because the stream is something like a pipe, and the execution relies on the stability of the pipe. Another thing is, I mentioned it's a push stream, and even if you take a look on the Java 8 stream, it's still a pull stream. You have to invoke a terminal operation on the Java 8 stream to signal, I want to process that data. That takes a while, and in contrast to that, a Reactive Streams publisher is a push stream, which data is pushed from the I/O side. And another thing which comes also into play is Reactive Streams is demand aware, so it won't overwhelm your service in case the database is faster than your front-end processing, and that's called back pressure. So, what do we do with that and Spring? Well, if you want to use reactive data access with Spring, we have certain preconditions to that. The first thing is you need Spring 5. Spring 5 is based on Project Reactor. Project Reactor is an implementation of Reactive Streams, providing multiple types to implement data access. And the last component in here is that you need Spring Data 2.0. And for those guys, for those people who are really excited about Spring 5, well, there's a release date. We are expecting Spring 5 mid this year, and shortly after we will release Spring Data 2.0. But the good news is there are already snapshots available and even milestone builds, so you can try out all that stuff. And you will see after the presentation also links to the examples repository, to the slides and so on, so you can take a moment at home or at work and go through these examples if you want to learn more. So, Project Reactor comes with two types, and these two types do not sound like publisher. They are mono and flux. But the good thing about these types is both implement the publisher API, that's an interface, and the reason why Project Reactor does this is to express in the type the multiplicity of data you can expect out of that thing. See, it's not entirely unimportant to know whether you can expect one element or thousands or infinite, and that's why we went this way, providing mono and flux. So with a mono, you are able to receive 0 data elements, 1 element, or an error signal. And with a flux, you can receive either 0 data elements, any number of elements, or an error. And this any can be also an infinite number of elements. So you are not limited by any count that you have to know upfront. So what does Spring Data provide us? Well, Spring Data provides us reactive support on multiple levels. Who of you is using Spring Data today? Cool, great. So you are maybe familiar with the Template API and the repository support. And if not, I'm going to do a live coding session with you right now to show you and explain what these things do. Notice on the supported data stores, well, we do not support all data stores that we have Spring Data modules for, but we support MongoDB, Apache Cassandra, Redis, and Couchbase. Things like Elasticsearch, Solar, and JPA aren't supported. So let's take a look on the code. And I have to set up my monitor right. Yeah, okay, cool. Do you see that? Yeah, you see that. Cool. Do you know start.spring.io? And for everybody that does not know it, start.spring.io is the home to start your project with Spring Boot. And with Start Spring Boot IO, you can select a version you want to base on, and for reactive data access, we need Spring Boot 2.0. It will be released around December, and we have already integrations for reactive MongoDB support. We have reactive web support, that's called WebFlux. I will take into my mix Project Lombok, because I'm a lazy guy and I do not like boilerplate code. Generate a project. Let's download it here. Let's open it in my IDE, a wonderful, precious IDE. So here we go. I need one more additional dependency. I'm going to do this example with MongoDB, and since I do not have a running MongoDB on my machine, I will use flapdoodle, which will spin up an embedded MongoDB process. Okay. Cool. So let's start with a simple domain object, which is a document in MongoDB terms. It's a data element that's a Lombok annotation actually, which prevents me from writing getters, setters, constructors, and all these things. Let's put a required arguments constructor on that, and it's a static class person. Let's give it an ID, string ID, and let's put in a simple property name. Okay, that's this part. Now I want to persist that person object in a repository. And what do I need to do that? Well, I need a repository API. So let's define an interface, reactive person repository that extends from reactive CRUD repository. So for all of you who already know Spring Data, we have a CRUD repository, and the reactive version of that is simply called reactive CRUD repository. And there you can define your entity type, the ID type, which is string in that case. And now I have a reactive repository support. Huh, that was easy, huh? Well, as an interface, that's not everything I need to do, but I have to also enable reactive Mongo repositories and consider nested repositories to true. Otherwise, Spring Boot won't find that. So that's a cool thing. Let's inject that. Adding required constructor, final reactive person repository people. So that's a structural thing. Now I want to put in data into that repository, and I'm taking a shortcut by implementing command line runner in Spring Boot. That's one component which isn't entirely perfectly named because, well, I'm running it from the IDE, so it has no relation to the command line whatsoever. But still, it's a good thing to execute stuff within a Spring Boot startup. So, and I think I need a little bit support from your side right now, because I need a couple of names. What's your name? Victor. Whoop. Victor. What's your name? Maria. That's right? Perfect. Anybody else? What about you? Andrea. That's okay. Okay, cool. Another one? How about you? Yes. Well, I think yes. We need diversity. Well, it's not only about girls here. Marius? Thanks, Marius. And okay, let's be that. So what I'm going to do now is I'm going to use reactive data streaming to store these names in a database, And because it's only just half the fun just storing data, I will do something special with that. I will create something called an emitter, which emits every second an event. So every second a name will be saved to the database. And I'm using a Java stream for that to generate items on a random basis. Let's take a random, new random. Have a lambda for that, names. Do the array access, r.next int, 1, 2, 3, 4. Then I'm going to map that to person new. And, whoops, I did something wrong. Width. Okay. I forgot here. Yeah, thank you. Forgot to make that final. Good. And the stream part is only one part of that, and that's still a blocking piece. But that's my entrance to the reactive world, because now I'm going to create a flux out of the stream, from the stream, and every time somebody requests data from the flux, it starts emitting a person. So let's put that away so we can see that. Now I need another component which emits events on a time basis. That's flux.interval duration of seconds 1. Zip it together with the person flux. So that's going to merge the elements which are emitted from the streams. It's a person flux. Map it tuple. Tuple2, here imported get 2, and flat map it with the repository. So that's going to save now the element in my repository in a reactive way. To show you that something is really happening, I'm at a do on next element system out println. And the terminal thing to kick that off is called subscribe. So at this point, I'm sending a signal to all these reactive elements to kick off with their work. And let's start now the application and see what happens. In case I didn't do too much of a mistake. Okay, so things are happening. You see something on the console is going on. Marius, Victor, Andrea, and so on are inserted to the database. Let me grab then, no iTunes. Let me grab then my MongoDB client. Mongo with minus port. Put this port in because that's an arbitrary port number because that's an embedded Mongo server. And let's query the collection, which is person count. You see 38, 39. So that's inserting data already in the background. And the nice thing about that is you would expect this run method to be blocked in a regular application, but actually it's not blocked. It's moving on with its work. So we will see that in a minute in the console. You see, go on, and it starts emitting data and writing the data right into the MongoDB. So that's already fun, but I think we can do better by exposing that data with, let's say, a web endpoint. Let's take a look on that, how this looks like. I'm going to write a web endpoint with the Spring Web Flux component. That's similar to what we have today with WebMVC, but Web Flux is opinionated about being reactive, and you can't mix the things you receive from Spring Web MVC because in the end, Spring Web Flux requires a server like Undertow, Netty, which does not really provide a servlet API. And also the servlet API is not capable of dealing with reactive data access. So we have to use something which is running on an event loop and does not and allows us to emit data at arbitrary times. So let's create a static class person controller. That one is annotated with REST controller. So when you start using these annotations, they are pretty much the same what you find with Web MVC. So there's nothing really new to learn, but you're still constrained by the capabilities of what Spring Web Flux provides to you. So I'm creating a get mapping, put it to the root, and the type I'm returning is flux of person. So normally you would return here a list or an iterator or whatever type you have. In this case, WebFlux is accepting reactive types, which encapsulate the whole notion of execution and the whole stream. And WebFlux subscribes to this resulting stream and starts streaming data directly to the output as soon as data comes in. So let's call it get people. And because I need a repository, let's add another required args constructor, final reactive person repository, people. And now I'm just returning this. So, pardon? Okay. So things are happening right now again in the console, and let's take a look on what we get with curling that. No, that's not a stream, and I want to have with I. And you see some things are starting to come in. They are getting more and more, and let's have a nicer look on that with JQ, and you see. The data is starting to come into that. Some very rare cases you might want filter data. Well, actually you want to do it quite often. So what you can do with that repository support is creating declarative query methods that derive their queries based on the method name. So find by name. And let's put in here a name, pass it into there, create a function which returns a flux of person. Now I can again run the application, get to the terminal, and right now the result is empty because I haven't specified the parameter. Let's put a name into there, Marius. Yeah. Oh crap! so you see the number of Marius is growing, and I'm duplicating you. So that's a pretty good cloning machine. No, just kidding. You would pass in parameters into that API the same way as you would do with a blocking API. So nothing changes in that. And I've seen quite a couple of hands previously that were using RxJava. And although we are opinionated in the template API about the underlying reactive library, we are not opinionated about that in the repository layer because, you know, these kinds of methods are dynamically, and as soon as you have a particular library on the class path, we can take advantage of that. So you are not limited to use Flux, or to say it in a different way, you're not forced to use Project Reactor if you do not like to. If your team is comfortable with using RxJava, well, simply add two dependencies, which is dependency RxJava, the first version. The support for the second version of RxJava is about to be merged in the next couple of days, so we are progressing also on that front a little bit. And the second dependency is RxJava Reactive Streams. That's the actual bridge between RxJava and Reactive Streams. So this dependency does all the adoption. And then, well, you can take this observable, place it here, run it, and you're happy, I guess. Go on, yeah, sure. Let's see whether Marius has already arrived. No, Victor, Maria. Ah, here we go. So you simply change the type, we do the adoption for you, and you can use whatever favorite library you're using, and can go on with that. So I think, I'm still not convinced that reactive is a thing, so let's try something new with that. Anybody of you heard of server-side events? Server-side events? Event streaming? Yeah, quite a couple. So the notion of server-side events is, well, compared to a normal request like I had it here, is you have a request, you post out data to the recipient, and you have a defined end. So request, data receiving, and you get that data. There are, however, use cases, something like chat rooms, an event log, or log stream, which make it quite hard to deal with that particular case of always polling the server, because you create a lot of traffic on the server side, and that's not healthy for the server either. So there comes server-send events into play, and what server-send events is basically doing is it gives you an API to push data to the client as soon as it arrives. But the downside is it's not part of the serverless spec yet. Every implementation has its own approach how to deal with that. So Jetty has an API, Tomcat has an API. And if you decide to use one implementation, it won't work with another implementation. So that was reason enough for us to say, okay, well, let's use server-send events in Spring, and let's see how this plays with reactive data access. And let me quickly show you how this works. Get stream. That's one thing. Another thing is I have to declare that I want to produce media type. Media type, yeah, here we go. Text event stream, that's one thing. And the other thing is our data source needs to support that as well. And MongoDB has this nice thing of kept collections and tailable cursors. So that's something which is very similar to ring buffer. And we can take advantage of that by creating an infinite stream based on tailable cursors. And all you have to do is provide a Fiori method. Let's call this just find by to find everything, and put infinite stream on that. And that's and what's happening right now is the stream is infinite. You can't predict how many data is coming through that, so that's actually a good thing. And it terminates when the subscription to the stream terminates. So the subscriber is now more in charge of controlling how much data is coming through the stream. And what I need to do right now is I have to create a kept collection. So that's a term in Mongo they use with our Mongo operations. So Mongo operations, and what you might notice is I'm using the blocking Mongo operations here. And to be honest, reactive data access isn't the answer to all of our problems. In some cases, especially when we start mixing synchronous code with reactive code, it might cause quite a headache. Because see, in this run method, that's a synchronously called method, we would have to synchronize somehow, and synchronizing streams is possible, but it doesn't read nice, because you have this block method, and that's some sort of a red alert signal. If you see somewhere blocking access with reactive streams, you should be aware, okay, that's nothing you really want to do with that. So in a lot of cases, you are better off with sticking simply to Synchronous API, especially when you are starting to populate your data store or doing initialization stuff where other stuff is just depending on that. Because a lot of APIs will still remain synchronous. So that's a pretty good reason then to use blocking Mongo operations. Now I want to create a kept collection for person class, specify collection options, put in how many documents I want to have in there. So 1,000 byte size, 1,000 documents, and true that it should be a kept collection. That's one thing. The other thing is I need to fix the REST controller right now, put in the right method, and declare the right endpoint. And then I'm basically good to go with server send events. So let's run this. Okay, cool. Things are happening right now. And because I'm not having an argument right now, I'm accessing the stream directly. And what you can see is, as soon as data arrives in MongoDB, it's published through the event stream, submitted as server send event. That's the JSON for that. And I could go like forever right now and consume my stream. And the nice thing about that, the threads which are underlying and used for all that work are utilized only for the time when data is available and data is pushed. Otherwise, they are immediately released to the thread pool, even though I'm using things like stream and so on behind that. And that's the thing you get as a benefit from reactive streaming. So that was the quick demo session on live coding with reactive streams. I will push the code to GitHub. So let's simply do that. Git push. Oh crap! Please no. I will push it to repository, which is named. Yeah, bad preparation. Here we go. Which is named then MP911DE Vox Days Bucharest. So I have to figure out what I did wrong on the console. They will find the code of the live coding session. We have also some more code and more examples. And you can find all that examples in the example repository. One thing I didn't show you yet was the Reactive Template API, and we provide with reactive support. These APIs are very opinionated on the underlying driver. So for MongoDB, Redis, and Apache Cassandra, you will get project reactor types on that. So where in every method where you returned T in a blocking model, you will receive a mono of T, and so on. For Couchbase, they are using RxJava, so the whole template is also RxJava based, and you will find observable, single, and these kind of types on that. So Mongo, we have that. So to wrap it up, Spring Data Reactive brings you an end-to-end reactive experience, and it's guaranteed from the framework side and from the driver side to never block in any of that process. We can integrate with RxJava, RxJava 2, and whatever framework, or better say, whatever composition library there will be to wrap reactive types. You get infinite streams. Right now it's available for MongoDB. We are planning to publish that also for Redis, where you have PubSub, and you can listen for an indefinite amount of time for PubSub messages, and that's making things really quite fun. So if you have any feedback, it's welcome. Mulțumesc. Find the slides here. Find me also on the conference. If you have questions, then I guess that's right now the time to ask those. Okay. Okay, so the question was between MongoDB and the HTTP API, what technology is used to communicate? Simple answer, it's just simple HTTP. The client does not know about the reactive infrastructure on the server side, and that's also one of the challenges to make the client not being opinionated about what's happening on the server. We can use WebSockets, but that example right now was plain HTTP. Yes, that's a Hollywood principle. Don't call us, we call you. Yes, that's all within the stream. So, next question. So the question is, are we expecting reactive support for SQL databases, or let's phrase it for relational databases using ACID? So the short answer is no. The longer answer takes a bit to explain, but I try to summarize it. See, our understanding of reactive is to maximize resource efficiency. With relational databases, you don't have right now any API that's asynchronous, because see, JPA is synchronous blocking, JDBC is synchronous blocking, and the only driver available for asynchronous data access is Postgres. Oracle is working also on a driver, but yeah, okay. That's one thing. The other thing is, see, the intrinsics of a relational ACID compliant database is to create transactions on every request you do. So you select something, you get a transaction. You update something, you get a transaction. If you run 2 queries concurrently, transaction is isolate between these calls. And if you do 2 concurrent updates on a ACID database, one is locking, the other one is waiting, and then it gets released. So you're moving the synchronization part from the application towards to the database, and you basically end up again with synchronization on the database side. So that's nothing which plays nice with the reactive data access idea. Yes, question? Okay, so the question was, how do we handle back pressure? Well, back pressure is a thing to let the publisher know how much data you are capable to handle. So that's an information which is flowing continuously from the subscribers back to the publisher. So that if you have a slow publisher and a fast producer, so imagine the database is pumping out data into your application, memory runs out in your application, that's nothing you want to have. So the back pressure is to regulate the volume at which the data source emits data. And Reactive Streams has built-in back pressure support. So that means when you subscribe to the data source and request data, you pass in a number which describes how many data elements you are able to process. And once you processed that, you can again request data and give the publisher an indication how many data you can handle. And the thing about back pressure is you can optimize a lot on the publisher side, because the publisher can either submit data from a buffer or request data asynchronously, just as an optimized streaming, so to reduce lagging on the client side. And every time you request data, you tell the publisher basically how much you want to have. Yes, question? Yeah. So the question was, will it be released in December 2017? Spring Boot 2.0 will be released in December this year. Spring 5 is going to be released in June, July, something like that. And Spring Data will be released as a final GA release shortly after Spring 5. But today you are able to play with milestones For Spring Data, we have a milestone, and if you're feeling adventurous, just use the snapshots like I did, and luckily nothing broke. And Spring 5 is available as milestone 4 or 5, something like that. So how does it work? So, so let me see whether I have something. Ah, yeah, here we go. Thing is, we need dedicated drivers because the today's MongoDB driver is blocking and synchronous. So that's not going to work with reactive data access. So we have to use the reactive MongoDB driver, which is available as Reactive Streams. For Redis, we have an asynchronous and event-driven driver, which works pretty well with reactive data access. For Couchbase, there's a reactive driver that's doing all that stuff. And for Apache Cassandra, we are using the asynchronous drivers. And how these drivers are supposed to work, well, it depends a little bit on which driver you're using. With Redis, well, basically all the Netty-based drivers, data is written out to the non-blocking socket via an event loop thread of Netty. And as soon as data arrives on the response channel, it's also propagated from the Netty thread back to the application. Does this answer your question? Okay, cool. So, pardon? Should we? So the question was, should we expect reactive streams for graph databases? Well, currently we have only one graph database supported, which is Neo4j. I do not know the current state. I have heard from Michael Hunger, which is one of the key people on the Neo4j side, that they are working on something, but we do not have something tangible yet. Okay, cool. So then, thanks a lot for attending my session.